In this lesson, we are going to learn how to write the electron configuration of an element using the subshell notation. The illustration on the left is the orbital order, which actually, to me, is the concise version of a periodic table. From our previous lesson, we learned that the periodic table has 7 rows or 7 periods. So the numbers that you see right here on the left side, 1, 2, 3, 4, 5, 6, 7, are the energy levels or the periods in the periodic table. S, P, D, and F are these sublevels. So there are 4 sublevels. The S sublevel can hold a maximum of 2 electrons. The P can hold 6 electrons, D can hold 10, and F can hold 14 electrons. So we are going to write out the order for filling the orbitals with electrons. So we're going to read this diagonally from the top right to the left, bottom left, and then again we're just going to follow the arrow until we get to the next energy level. So we're going to start with 1s. Let me go back, sorry about that. So 1s. Okay, so the first one that we see is 1s. And again, s can hold a maximum of 2 electrons. So we're going to write that as 1s2. Okay, so again, we're going to follow the arrow and then we're going to get to 2s. Okay, 2s. So s can hold 2 electrons. So 2s2. Okay, again, just follow the arrow and then we're going to take, it's going to take us to 2p, and p can hold 6 electrons, so that's 2p6. And again, the next one would be 3s. Okay, so 3s2. Next, after 3s2, 3p6. Okay, so p can hold 6, so 3p6. So just basically follow the arrows until we get to the very end, which is 7p6. Okay, so right here. So this whole thing, this illustration, the orbital order, is basically written out as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, and 7p6. Now let's do some examples. What is the full electron configuration of Br? Okay, bromine has an atomic number of 35. Let's see if I can work my pen. Okay, so 35, that means it has 35 protons and 35 electrons if the atom is neutral. So 35 electrons. So basically here is the subshell notation. So we're going to start from 1s2. Okay, so what we're doing is basically just counting the number of electrons. So 1s, 1s2. Okay, next is 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p. Okay, I'm not going to write anything in the top yet because I want to make sure that we're counting this correctly. Okay, so we are trying to find basically 35 electrons. So we're gonna count all the superscripts. Okay, the superscripts are the number of electrons. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30. So then 4p, 5. So that makes it 35 electrons. Okay, so that is basically the atomic number of bromine. So the next question is, how many valence electrons will you find in bromine? Okay, valence electrons are the outermost electrons. So how many electrons are there in the outermost shell? of that atom, okay? So the highest energy level here is, let's see, 1, 2, 2, 3, 3, 4, 3, 4. So 4. So there's 4 energy levels. So these are the highest energy levels, and there's 2 electrons and 5 electrons. So 2 plus 5 is 7. So the valence electrons, so bromine has 7 valence electrons, or 7 electrons in the outermost shell. Calcium, write the full electron configuration of calcium, and calcium has an atomic number of 20, which means that it has 20 protons and 20 electrons if the atom is neutral. Okay, so we're trying to find 20 electrons. So again, we're just going to count and add our superscripts, which are the numbers of electrons. So 1s2, 2s2, 2p6, 3s2. We're gonna stop counting until we get to the numbers that we're looking for, which is 20. Okay, so 3p6 and then 4s2. So again, to verify, we're going to count each one of the superscripts. So we have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. Okay, so that's it. That's what we're looking for. So very good. So the full electron configuration of calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now, how many valence electrons? Valence electrons, again, the outermost electrons. How many electrons are there in the outermost shell of calcium atom? Okay, so we're going to look at the highest energy level, which is in this case 4. Okay, this is the highest energy level. So, and it has 2 electrons. Okay, so there are 2 valence electrons in calcium. Next one. Si has an atomic number of 14. What is the electron configuration of Si, or silicon? Okay, so we're going to count again. So 1s2, 2s2, 2p6, 3s2, 3p. So before I write the superscript for p, I'm going to have to count all my electrons that I have so far. Okay, so 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, and we need 14, so therefore 3p2. Okay, so that is 14, and we got that. So the full electron configuration of silicon is 1s2, 2s2, 2p6, 3s2, and 3p2. Now, how many valence electrons in the outermost shell? Again, the highest energy level here is 3. Okay, so we have 2 plus 2. So the valence electrons would be 4. I hope you learned something from this video, and if you have any questions, please don't hesitate to email me or talk to me after class. Thanks, have a good day.